skaters collide and embrace. One skater has a mass m1 of 80 kilograms and is initially moving east at a speed of 2 meters per second. The other skater has a mass m2 of 50 kilograms and is initially moving north at a speed of 2.25 meters per second. A. What is the velocity of the couple immediately after the collision? B. What amount of the initial kinetic energy of the skaters is lost because of the collision? These graphs show the problem of the collision. M1, which is the first skater, is moving east on the x-axis, while the second skater, M2, is moving north on the y-axis. After the collision, they take on a new direction of theta, and it's on a tangent. So then, we begin A. by putting the y component of m2 times v2 is equal to m1 plus m2 times velocity times the sine of theta, divided by the x component, which is m1 times v1 is equal to m1 plus m2 times the velocity times the cosine of theta. The reason why we put the y component over the x component is because we want to find tangent, and tangent is sine over cosine. So then, by doing this division, we can eliminate m1 plus m2, and then our new equation will be tangent of theta is equal to m2 times v2 divided by m1 times v1. So then we plug in the numbers of 50 kilograms times 2.25 meters per second divided by 80 kilograms times 2 meters per second, and then we get the tangent of theta is equal to 0.703125. To find theta, we get the inverse of tan, and so we get the angle 35.1120118 degrees, which is the direction of the new, velocity. So then we take the y component and we simply isolate v to find the final velocity after the collision, and then v will be equal to m2 times v2 divided by m1 plus m2 sine theta. We plug in the numbers and our new angle, and then by solving for v, we get 112.5 divided by 74.77297775. Our final velocity, which is the answer for part A, would be 1.50455423 meters per second. So then part B asks how much kinetic energy we lost in the collision. So then we begin with the kinetic energy at the beginning before the collision. Kinetic energy is equal to half m1 times v1 squared. So then our initial kinetic energy would be half m1 times v1 squared plus half m2 times v2 squared. We plug in our numbers, and we put in our 80 kilograms times our 2 meters per second squared plus half times the 50 kilograms times 2.25 meters per second squared. We get 100 plus 126.5625, and then by adding those two, we get our kinetic energy initial, which is equal to 286.5625 joules. Now, to find the difference, we need to find the final kinetic energy, which is after the collision. And that would be half times m1 plus m2 times the final velocity, which we found in part A. Plugging in the numbers for this new equation, we solved that the final kinetic energy would be 147.139423 joules. So then, taking the initial kinetic energy minus the final kinetic energy is equal to 139.423077 joules. If you divide this number by the initial kinetic energy, it yields us the percent of the change, which is more than 48%. It yields 0.476536347, and that's the amount of kinetic energy that was lost. And that's finishing on part B.